Consider the functions f of x is 2x plus 1 and g of x is x minus 1 over 2. Let's suppose we do f of g of x. That means we do f of x minus 1 over 2. F takes whatever is input, doubles it, and then adds 1. So we're going to get 2 x minus 1 over 2 plus 1. The 2's here cancel, so we get x minus 1 plus 1, which is just x. So we put x originally into g. The output from that went into f, and we got x back. Now consider doing g of f of x, so doing it the other way around. So we get g of 2x plus 1. G takes whatever the input is, takes 1 away from it, and then divides the result by 2. So we have 2x plus 1, then we take 1 away from it, and then divide by 2. So that's 2x divided by 2, which is x. So we took x, put it into f, put the result of that into g, and we got x back, just as we did when we did it the other way around. We could look at this as a diagram. If we take x and we put it into the function f, out comes f of x. When we put that into the function g, we get x back. So we have x at the start, and we get x back here. We did it the other way around. We put it into g first. We get g of x out. We put that into f, and we get x back. So we start with x, and we finish with x again. Clearly g undoes whatever f does, and f undoes whatever g does. Functions like this have a special relationship. They're known as inverse functions. Usually, if we have a function f of x, we write its inverse function as f minus 1 x. But note, this is not a power. It does not mean 1 over f of x. This is just a notation that tells us that this is the inverse function. So here g is clearly the inverse of f. If we have any number at all, say 2, and we input it into a function, and the output from this is then input into the inverse function, we get the original number back. If this is the domain for the function f, all the numbers in the domain are mapped into the range by applying the function f. We've seen this in previous examples. Clearly, the inverse function just takes all of these numbers over here and maps them back to where they came. So the range for the original function is actually the domain for the inverse function, and the domain for the original function is the range for the inverse function. In the next video, we'll look at how to find the inverse function.